Hi, welcome to this video session. Today I'm going to talk about some problems related to integrity in the CBC mode. First, I will explain what integrity means in our context, and then I will talk about some approaches to solve this problem. Okay, let's get straight into the CBC mode and refresh our memory how it works. Yeah, we need an initialization vector, which is a random number usually. Plain text is organized as a collection of blocks, multiple blocks. Plain text is XORed with the initialization vector to feed into a block cipher encryption algorithm, which could be AES, for example. And then we use an AES key. We are using AES as an encryption key to encrypt that particular block to get some ciphertext. That ciphertext is XORed with the next block of plain text, again encrypted to produce the next ciphertext, and so on. Okay, so what is the integrity problem in this context? It's clear from the structure that if the plain text, let's take the first block. If I modify the first block of ciphertext, what will happen? It's going to affect the decryption process in an interesting way. Let's look at the decryption process now. If the first block of ciphertext is modified, let's say I modified it at this point. Let's say I modified it at this point, right? Just here, over here. That modification will, of course, corrupt the first block of plain text because according to block cipher algorithms, if an input is modified slightly, you would expect the complete output to be corrupted. So modifying the first byte of ciphertext will usually give us complete gibberish, which I'm going to show you now. Furthermore, that modification will also actually affect the next part of the output as well, because the way it is working is that the second block of ciphertext is decrypted and then it gets XORed with the previous block of ciphertext to recover the plain text. That's how we encrypted at the first place. We encrypted the second block of plain text by taking the first block ciphertext, XOR it with the second block plain text. Therefore, we need to do the same in the opposite direction. After we decrypt the ciphertext, what actually we decrypted is basically XOR of the plain text with the previous block of ciphertext. That's the reason why we do this way. Okay, so if we modify the first block of ciphertext here, let's assume I modify the first byte of the ciphertext here. This is going to affect the first byte of the plain text that's coming out for the second block of plain text. That's what I'm going to show now. Okay, let me get into the demo first. What I'm going to show you is the integrity problem first. Integrity problem. Okay, so I have this plain text made of a bunch of A's, 16 A's and 16 B's. I'm just going to modify the ciphertext in a way that we can escape any of the runtime errors. So let's first run this code first of all. Okay, so what you see here is that there was a random IV and ciphertext was produced for our plain text. And the plain text itself is shown here. Okay, so this is the plain text after we decrypt it. Okay, so there is so far no editing, nothing happened, no modification to the plain ciphertext whatsoever. Now let's do some modification to the ciphertext. Okay, let me just change the first byte of the ciphertext. Okay, right, something like this to 0. Okay, so we would expect the first block now to go gibberish because of the way the block cipher algorithms work. So we shouldn't be able to see all these beautiful A's that we are seeing here. Okay, they should go away. As you can compare, the previous run, we got all of our A's and B's properly. Now in this run, we got gibberish for the first block. Further, we can compare the number of B's we got. As we can see, we have 16 B's here, right? But here we have only 15 B's, as you can 4, 6, 8, 10, 12, and 15. We can also compare it using word counts to be confident. As you can see, 15. So the reason why we are only getting 15 B's is that because we modified the first byte of the ciphertext of the first block, it affects the second block's plain text. The first byte got corrupted as well. Okay, anyway, the first block is completely gibberish. That's because of the way how block ciphers are supposed to work. They are random functions. Okay, anyway, so what you are seeing now is that CBC has no built-in integrity. You could modify parts of the plain text and have an interesting effect when the decryptor is decrypting your ciphertext. Okay, so you could modify the ciphertext, of course, in a controlled way and have significant implication during decryption process. I have deliberately modified the first block because if you modify the second block, you may get into some padding errors which I have not talked about yet. So at this point, it's enough to show to you that CBC has integrity problems, right?